Hi guys, we're back. This is the second part of our 8-1 unit, and we're talking about our special right triangles in this one. So last year, you'll hopefully remember a little bit, we studied two special right triangles. One was a 45-45-90 triangle. The other was a 30-60-90 triangle. They have what we call, the sides have ratios. They have set ratios for each side. So in our 45-45-90 triangle, let's talk about this one first right here. We know there's a relationship between angles in the triangle and the sides that are across from them. So since these two angles are the exact same, the sides that are across from our angles right here are also going to be the exact same. So these sides are equal. Whatever this side is, this is the same one. So we're just, for our intents and purposes, we're just going to call this side x, which means this is x as well. Now, last year we went through the whole Pythagorean theorem and found this missing side or missing hypotenuse, but I'm just going to give it to you. It was x square roots of 2. Okay, so you're just going to memorize this ratio. This is whatever x is, but this hypotenuse is always x times the square root of 2. So in your notes, let's just go ahead and write down our legs are x's and our hypotenuse is x squared roots of 2. Okay, we've got the same ratios, different ratios, but we've got the same type of concept over here for our 30-60-90 triangle. Across, and just memorize these. Last year we proved them, but I'm just going to tell you, go across from your 30-degree angle right up here, and we're going to call that side x. Okay, I always go across from my right angle next. That one's the next easiest one, I think. This one is 2 times x. And then across from your 60-degree angle right here, this is x square roots of 3. Oops, can you see that's a 3? Let's try that again. So x times the square root of 3 right there. All right, so our shorter leg, that's the one across from the shortest angle. So across from our 30-degree angle, this one was x. We'll do the hypotenuse next. So across from our biggest angle, or our right angle, that was our 2x. And this longer leg, what they call the longer leg, that's our x squared roots of 3. All right, now you're going to use these nice little values that we've discovered, or I've just told you to memorize, to solve triangles that they only give you one side. So when you use the Pythagorean theorem earlier, they would give you 2 sides of a right triangle, and you can always find the third. But for these 2 special right triangles, you only need one side, and you can find the other 2. Let's look at the examples. Okay, so looking at this example right here, first thing that I notice is this is a 45-45-90 triangle, right? So when I go through to do this, I am going to label my triangle. I'm going to go across from my 45 angles, and I'm going to call them x. Across from my other 45 angle, call it x. Across from the 90-degree angle, and call it x squared roots of 2. So again, these were just ratios that I told you memorize. They're always going to be those ratios in a 45-45-90 triangle. Then I kind of look and I say, oh, look, what side did they give me? They're only going to give you one side in these special triangles. So I kind of circle it. They gave me what x is. So right here, I know that x is equal to 10. Now you can just plug this in for x on all of the other sides, and you found all the sides. So this side right here, x is just equal to 10. So I'm going to kind of ignore their x's and y's for a minute. Over here, we're going to plug this in for my x right here, and I have 10 squared roots of 2 right there. So the side that they're calling y right here, the side that they're calling y is my 10 squared roots of 2, and the side that they're calling x is just going to be 10. And you're done. Okay, now same thing on this problem over here. Let's go ahead and do the same thing. I label my triangle first. So go across from a 45 angle, call it x. Here's my other 45-degree angle. Across from it is x. And then across from my hypotenuse is x squared roots of 2. All right, now they only give you one side again. When we see that side right there, I know that my x squared roots of 2 is equal to 16. Now you're trying to solve for x, so you can just plug it into the other sides. So normally when we've got x multiplied to something multiplied to that square root of 2, we can just divide by the square root of 2 to undo that multiplication. That way I'm left with x is equal to 16 divided by the square root of 2. However, remember we've got a rule that says that they do not like us to leave radicals or square root signs right here in the denominator of a fraction. So to what they call rationalize the denominator, we're just going to multiply both the top and the bottom by whatever is in that radical right there. So when I go through and multiply it, remember you cannot multiply under the radical with numbers outside the radical. So when I multiply 16 times the square root of 2, it is just 16 times the square root of 2. Okay, down here though, they're both under radicals, so I could go ahead and smash them together and just make them under one radical. Square root of 2 times the square root of 2 is the square root of 4. But we know what the square root of 4 is. That's why we wanted to do that. The square root of 4 is 2. So I now have my rationalized denominator right here. And we can clean it up even one step farther because now we've got two numbers, 16 and 2 are both out of the radical. We could go ahead and divide them. 16 divided by 2 is 8 square roots of 2. So that is our x. This x is right down here. So x right there is 8 square roots of 2. When I go through to plug it in, this side is x, so I've just got my 8 square roots of 2 and 8 square roots of 2. So what they're calling x right here is this 8 square roots of 2, and what they're calling y is also 8 square roots of 2. Not too bad. That was probably the hardest one that you're going to do, just having to rationalize the denominator. Let's look at the next couple of examples. Okay, another one that is a 45, 45, 90 triangle. So across from my 45-degree angle, there's x. Across from my other 45x, and this is x squared roots of 2. Okay, we find our side that we know. They only give us one side. It is our x squared roots of 2 side. I know that that's equal to 14 squared roots of 2. Some of you can just tell me what x is, but if not, go ahead and divide by that square root of 2. And they cancel. So x is just 14. Then you just plug it in for x. On both sides, they're both 14. So what they call x is 14, and what they call y is also 14. Not too bad, right? All right, now let's look at our 30, 60, 90 triangle. This one's a little trickier to memorize, but not too bad. I'm going to label my triangle first on this one too. So go across. I always start with my smallest angle. So that 30-degree angle, you're going to go across from it and call it x. Okay, I jump to do my biggest angle next. So I'm going to jump to my 90-degree angle. Across from that, my hypotenuse is always 2x. And that leaves our last one. It leaves our 60-degree angle when we go across from it. That is our x squared roots of 3. Okay, again, we're just memorizing these ratios right now. X, 2x, and x squared roots of 3. And then again, same thing as the 45, 45, 90 triangles. You're just going to find the angle or the side that you know. So I know the 2x side. I know that 2x is equal to 8. Easily I can solve for x. It's just multiplied by 2, so I'm going to divide by 2. And x is equal to 4. Now we could just take that 4 and plug it back in for x. So this side right here is x. This side up here is, this side is 4. This side up here is 4 square roots of 3. Okay, and then I go back. The very last thing I do is I just look at what they're calling. So the y, what they're calling y, is my 4 square roots of 3. What they're calling x right there is just 4. And you're done with the problem. You found two sides of your special triangle. Whoops. Last one here, last two examples, another 30, 60, 90 triangle. So find your 30-degree angle. Across from it is x. Across from your 90 is 2x right there. And then across from the 60-degree angle is your x squared roots of 3. All right, so that is the side that they've given me. They told me that my x squared roots of 3 side is equal to 27. So I am trying to solve for what x is. Then I can just plug it back in to these two sides. Again, x is just multiplied by that square root of 3, so we're going to divide by the square root of 3. So x here is equal to 27 divided by the square root of 3. Okay, last step, remember they do not like the radical here in the denominator. Multiply by whatever is in the denominator. Okay, so you're just going to multiply by that square root of 3 over square root of 3. Really just 1. We can multiply by 1. And so I end up with 27 square roots of 3 divided by, and again, you can kind of smash those together because they're both under radicals. So I have the square root of 9. But we all know that the square root of 9 is just 3. So I really have my 27 square roots of 3 over 3. And we can clean that up just one more time. 27 divided by 3 is 9. And then we can put back in our square root of 3. So our x here is equal to 9 times the square root of 3. Now we just plug that back in. X is equal to 9 square roots of 3. 2x is equal to 2 times 9 square roots of 3. And this x, what we called x, they're calling y. So I'm just going to put my 9 square roots of 3 here for y. And then up here, I'm going to multiply my numbers. 2 times 9, they're both out of the radical, so I can multiply those. 18, and then the square root of 3 stays square root of 3. All right, again, that was the hardest one of those that you're going to do. So this one, when we label our triangle over here across from our 30-degree angle, this is x. So they've given us the side x first on this one. Let's keep labeling now. This side right here, across from my 90-degree angle is 2x, and across from my 60-degree angle is x square roots of 3. All right, so they've told me here that x is equal to 5 square roots of 6. That's what x is. So when I go up here to plug it in for my 2, I'm just going to times 2 by my 5 square roots of 6. Again, you can only multiply numbers outside of a radical with numbers outside of the radical. Okay, 2 multiplies with 5, and we have 10. What side is this? This is what they're calling x. So we have 10, and then you're going to still have it still all multiplied by that square root of 6. Okay, down here for this side right here, when I plug in my 5 square roots of 6 for x, and then multiply it by the square root of 3, this time I have two numbers that are under radicals that I can multiply together. So I've got my 5 times the square root of 6 times 3. Well, 6 times 3 is 18 right there. Now your instructions on your homework and the examples are going to say write it in simplest radical form. So please just note, remember that 18, I'm going to erase this just to give us a little bit more room to write right here. Remember that I can rewrite this 18 as 9 times 2. Reason I love to write it as 9 times 2 is because when I go to simplify it to clean stuff up, I know what the square root of 9 is. It's just 3. I still don't know what the square root of 2 is, so that'll stay. But now I can go ahead and multiply my 5 and 3 together, and I have 15 square roots of 2. And we're done. Thanks for tuning in. We'll be back with part C shortly.